So there we go. All right.
Remind me if I'm, because I kind of forget. Atwood machine is just a piece of pulley with two masses on either side, right?
Yeah.
Okay.
Oh, is that something you have to remember for the test?
No, they would
Oh.
just diagram it.
Ah, okay.
Well, for his test, I mean, maybe, probably, but AP no.
All right.
All right, where the heck am I?
You're looking at a smiley face? Ooh.
There we are.
Pulley radius of 0.25. Well,
Sorry, my bad. We're good.
all right. 50 kilogram mass, 20 kilogram mass, 1 meter, 2.2 seconds, some mass of pulley. Oh. This is gonna be not fun math. I can tell already.
All right, let's start by drawing it out. Okay, so basically from the this last part of the question, the 20 kilogram mass falls 1 meter in 2.2 seconds. We should be able to figure out the rotational velocity or the rotational um, acceleration rather of uh, the pulley, and then we also can find the net torque on the pulley, and then we know that if we know the net torque and we know the resulting rotational acceleration, we can find the um, rotational inertia, which will be a function of the mass of the pulley.
Oh wait, so you don't have to like make three different diagrams and then find out each equation for each mass? Because that's what he made. He like told us that that's the best way to like make three separate equations for each mass and including the pulley, and then like combine those all together to find the total. Um,
So wait, make equations for for what exactly?
like okay, so you know how for the 20 kilogram mass, you have a weight force and you have a tension that'll be like let's say tension one. Okay, and so then, well then the weight for like the 20 kilograms are gonna go like they're gonna accelerate downwards. So then it's gonna be T1 minus the weight force equals mass times acceleration, and then you have to like, you know, and then like you do that the same thing for the second mass, and then you find the equation of the pulley, and so you include that stuff into the equation of the pulley. And the problem is like when I kept doing that, I didn't get the answer that he got. Like I got some gigantic ass numbers like 114 when he got like 0.49 or something like that.
Yeah, I see what he's doing because what he's
I'm questioning his statement that that's the best way to do it. I mean, it's
it's
a way to do it,
it is a
sure.
way to do it, yeah, and it's always gonna get you the right answer provided you can follow that long set of steps. But so what he's doing is the uh he's just finding the forces of the tension forces, and then he's making systems of equations with and saying these forces must equal uh or this acceleration must equal that acceleration, and setting the and using the two masses to use the system. It's weird. It's like I can't think of how I would write that off the top of my head. I'm sure you could do
Yeah.
it, but yeah. It's a
Okay.
way to do it, but
Uh-huh.
not how I would do it.
If you were to do it your way, would the acceleration would be the same for both of the masses, right?
Uh,
Or no? Is that wrong?
they should be.
Okay.
Yes, the acceleration of both masses will be the same. It will always be the same because of just how it works. And then, since if you know the rotational, like, or the linear acceleration of either object, you can find the rotational acceleration um, of the
Yeah.
pulley.
Okay. So then, how would you do it? Would you do like force equals mass times acceleration, and then just do like force divided by mass equals acceleration, and you would do like the weight force of the first mass minus the weight force of the 20 kilogram mass.
So, I mean,
And
the way I would do it, personally, is I would find the torque that each and Alan, correct me if I'm wrong, because again, rotational motion is vague to me now. But
Mhm.
I would find the torque that each of those masses applies to for this particular problem. This doesn't work for all of them. This is just because of what it's asking for. I'd find the torque that each object applies to the pulley, which is just obviously its mass times the distance away it is from the center of rotation, which is the radius of the pulley, right? And then find net torque, which is just the same as net force. So one is pulling in the positive direction, one's pulling in the negative direction. So you subtract the two. And then once you find the net force, you can use your standard rotational equations. Normally, you would combine, um, the torque with the inertia of the pulley, or the rotational inertia of the pulley, to find angular acceleration. But you already know angular acceleration because you can get it from the fact that the 20 kilogram mass falls 1 meter in 22.2 seconds. So once you change that into being rotational acceleration, you just do the torque times rotational inertia is equal to that acceleration, solve for rotational inertia, and then from there solve for the mass.
Does that make
okay.
sense?
Yeah, it makes sense.
All right. That's the best way to
So
solve it, I think.
so to be fair, right? I would 100% use his way if and only if the mass of the pulley was non-existent, right? If it was asking you to find acceleration of the system and that said the pulley was massless, yes, I would agree that that way is best. But as soon as the pulley has mass, I disagree with that statement.
Yeah.
Does anyone need us to solve this out fully, or do you guys understand?
Yeah, could you solve it just like so we can see it like actually applied?
Okay. So hold on, let me pull up the formula sheet so I make sure I'm not doing anything wrong here. Okay, so we said the radius is 0.25. So let's get the weight force from each of these. So what is the weight force of the 20 kilogram mass going to be?
Like a little bit less than 200.
Yeah, and
Let's
we're just gonna use
let's just use
100.
10 as G. I don't
Okay.
understand why no one uses 10 as G. It just makes your math simpler, and that's what IB said.
It's probably because he doesn't, but whatever.
How did you get that 200?
20 kilograms times 10.
Oh,
10 being gravity in this case. Okay, so we know that torque is equal to the perpendicular force times the radius. We know the radius is 2.5, or 0.25, sorry. So, what is torque going to be? Well, why did I put kilograms here? Hang on, this should be newtons. What am I doing? All right, so what is the torque applied from the 20 kilogram box going to be? And also, we're going to say that going clockwise is positive in this case. All right, so we're just going to multiply 200 times 0.25. Sorry, I didn't realize you were going to say something.
No, you're good. Wait, but oh, is it just because it's greater? It's a greater mass, and that's the mass that's gonna make it rotate.
No, I just picked one to start with. There's no
Oh.
logic. We're going to have to do it for both of them. I
Oh,
just
okay.
picked this one to start with. So this one's going to be 50 newton meters, negative 50 newton meters, because this torque that's applied here, right, is going to spin it, would cause the motion to go this way, which we said is opposite of the way we've defined our axis. So this is going to be negative 50 newton meters. Then the mass applied, or the torque applied from the other one, is going to be 150 times 0.25, which is going to be, the torque from this one is going to be positive 37.5. All right, hang on, I can't write that close to the edge. So positive 37.5 Newton meters. And then we're just going to add these torques together, remembering that one of them is negative. So negative 50 plus 37.5 gets us negative 12.5 Newton meters.
So you're
Negative.
multiplying the mass times the radius, and then what are you doing?
So I'm finding the torque that each of these masses applies to the pulley, which if you look at your AP formula sheet is like one of the equations near the bottom, the one that starts with T, that gets you torque from force and radius, right? So I'm finding the torque that each of those applies to the mass, or to the pulley, and then I am getting the net torque. Remember that torque is the rotational analog of force, so pretty much everything works the same. If you have two separate forces acting on an object, the net force is the sum of the forces. Same thing with torque. If you have multiple torques acting on an object, the net torque is just the sum of the torques.
Okay.
Okay, so we get negative 12.5 Newton meters. And remember that it's negative, so it's really going to be spinning counterclockwise. And so that is going to be net torque. So the next part is we need to get linear acceleration from, or we need to get angular acceleration from linear acceleration. So we have, so first of all, it says the 20 kilogram mass falls 1 meter in 2.2 seconds, right? And we know that its initial, let's get the acceleration of the mass. So does anyone know how we would get the acceleration of the 20 kilogram mass? If we know it falls 1 meter in 2.2 seconds. So let's go back to our initial three kinematics equations. If anyone goes to the formula sheet, look at the top three. Of those top three, which equation can we use?
The final displacement equals initial displacement plus velocity initial times time plus 1/2 acceleration t squared.
Yep.
Okay.
So we can say its displacement is going to be 1 meter. So 1 meter is equal to initial displacement, which is just 0, plus initial velocity times time. Initial velocity is 0, so that just cancels out. And then we have is equal to 1/2 a t squared, and that t is 2.2. Sorry, I'm kind of going into the problem. T squared. And so now we solve for a.
How
So
come
I'm
it would be 1 for the final displacement? Because isn't it like, oh, never mind. Oh, whoops. Okay.
Yeah, it says it falls 1 meter in 2.2 seconds. So that's where 1 came from. Okay, so I'm gonna go ahead and solve for a. If anyone else wants to do it as well to make sure I don't screw up, feel free. Okay, so I got 0.413. Can anyone confirm that that is what they got as well?
That's what I got.
Okay. So if we know, so that's going to be the linear acceleration. Really, that's the acceleration of both masses and the rope as well. And remember that the rope, curves around the pulley. So that's equivalent to just the linear acceleration of any point on the surface of the pulley. So if anyone remember back to rotational analogs, how do we change the angular acceleration, or the linear acceleration to angular acceleration?
Did you say angular to linear or
No,
linear to
other way around. We have the linear acceleration now. It's
Oh, okay.
0.413. We need to get
Then
angular.
you just divide it by the radius.
Yep. So we would say that, how do you write the angular thing again? Oops. It's like this. Angular acceleration is equal to 0.413 over the radius, which is 0.25. And so the angular acceleration is equal to 1.652 or 1.653 with rounding. And that would be radians per second squared. So finally, we have our net torque. And if we go to the physics equation sheet, let me figure out where it is on here. So if you look right above the torque equation, it tells you that angular acceleration, which is this, is equal to net torque over rotational inertia, or I, right? So we know that angular acceleration was 1.653, and that's going to be equal to negative 12.5, which is the net torque, over rotational inertia, which is what we don't know. So solving for rotational inertia, that should get us negative 7.56. If anyone else is following along with the math, can you confirm that I got that right?
Yeah, that's right.
Okay. So negative 7.56. All right, and then lastly, what object can we treat the pulley as?
A disc?
Cylinder, cylinder, right?
Oh,
Yep.
okay.
Yes, so solid cylinder. So what is the rotational inertia of a solid cylinder?
If it's rotating around the central axis, on the thingy axis, it's mr squared over 2.
Okay, I'm gonna trust you because I honestly don't remember those equations. So can anyone else confirm that it is mr squared over 2?
That's right.
Okay, so the rotational inertia is equal to mr squared over 2. Rotational inertia. So this is the point where I'm going to take out the negative, because the negative in this case doesn't matter anymore, right? So even though there is a negative in rotational inertia, really the negative is coming from the torque and the acceleration. So actually, really, what it would have been is this acceleration should be negative. So when you do that, this actually cancels out. So sorry for missing that earlier. But you should always get, if you did it right, you should always get a positive inertia, rotational inertia. So we do 7.56 is equal to m. We know that this is 2.2 squared over 2. And finally, you just solve for m. And so that is 7.56 times 2 divided by 2.2 squared. The mass should be 3.12 kilograms. Anyone have any questions about that? That makes sense, Lana? I think that you were the one who asked, right?
Yep, it makes sense. I'm just trying to finish it. Oh, I got 241.92. What?
Could your calculator have not followed order of operations?
1 second. Okay.
I mean, I might have done it wrong, but I don't think I did it wrong. 7.56
That seems like a pretty reasonable number.
divided by 2.2 squared.
No, you're right. I just pressed something wrong.
Okay. So yeah, that's how I would definitely do it for these type of problems. I would not make 3 equations and solve it that way. That seems kind of annoying, in my opinion. I mean, you'd get the answer, to be fair. But when the pulley has mass, I wouldn't do it that way. When it doesn't have mass, then yes, I would agree with that. In fact, I'm pretty sure it's like the only way you can do it if it doesn't have mass. But
Are we allowed to, can we go over the FRQ? All three of us are here, I think.
okay, yeah, sure, let's do that. Okay, I will unlock them now. Okay, they should be unlocked. Go ahead. Yep.
I have to go right now. But thanks a lot for the help.
All right, no problem.
All right, have a good day. Bye.
Did you get the IB student? Or are we gonna go over her stuff afterwards?
Yes, I got, I don't know how to pronounce her name. Amania, I think.
Yeah.
Amaya. There's no N. Anyway, yes, but they left, and the other IB student who took it is also not here, so we're not gonna go over the IB one.
All right.
Wait, Ayo, sorry, I just got here, so like, did you guys already go over the AP one?
Nope. We're just about to.
No? Really? Excellent.
Okay, so let me.
Is Ellie here, or do I have to go yell at her?
No. You have to
Hold
go
on.
yell at her.
Let me go yell at her. I'll be back in a second.
All right, let me get the AP one. Drop it into the board.
God, it's so bad. Ooh.
So this one was hard. I will tell you the national average was 2 out of 7.
Go.
However, our average was higher. Our average was around like a 3.9. So, that's good. Oh wait, that's the IB one, isn't it? Oh, rip. Okay, hang on.
Hey, hon, what'd you get?
Hey gamers.
Hi, Motterwellen.
You're late, Ellie.
I forgot that this was a thing.
Hold on. If it's highlighted, it's wrong, right?
No, read the comments.
Where are the comments? There are
On
comments?
the right side. Yeah, on mine there are comments.
Huh? Oh wait, I
Hmm.
gotta open
That-
this in Drive. That's why I was looking at it as like a PDF.
No, you just
Bruh.
failed. Damn.
The top comment at the very top should be your total score.
Huh? Yeah, I didn't get that last time, so I was kind of confused.
Yeah, because you
Oh,
got a 0.
I mean,
out
it's
of 12.
there. Go back if you go back to the original one. The comments are definitely there. We definitely put them there. Just leave it in the Drive link. All right, so this one was deceptively difficult. Like it only had like 2 parts to it, but like I said, the national average was a 2 out of 7.
Nice.
Can I zoom out so I'm not like staring at just formulas?
All right, I'm back. Ugh.
What were you doing? You
I was
yelled
just in the
at me
bathroom
like
real quick.
some age.
All right,
Alright.
did everyone's things unlock?
I think we just still don't have Sophia here. I think that was still.
Yes, sir.
All right, hold on. So let me go to this.
Okay,
do this
and is
little-
everyone able to actually see the comments?
Wait, what did you say the high was?
Like the national high or ours?
Ours.
I think the highest was 5, right, Alan?
No, didn't we have one at like a? No, yeah, it was a 5.
Let's
Hey
go.
yo!
Yo.
Damn, what'd you get?
5.
Oh.
This is good because I completely failed the last one.
Let's go. I got a 7. Let's go.
I know. I thought.
No, you didn't.
I thought.
Hey.
Pretty proud, man.
What did you say, Alan?
Never mind. I'm 8.
Ellen got a 2.
Okay.
Failed.
Hey.
Garbage.
I mean, if it's any
Mom
consolation,
failed.
I do these FRQs myself before I give them to you, and I grade myself. I got a 6 out of 7, so I didn't even get 100. So to be fair, it is difficult.
What is this flex, bro?
But anyway, so before we go over it, how did you guys feel about it when you were taking it? What were your thoughts?
I freaking love this. This is like
So
Prime
easy.
physics.
Yeah, I mean, this is fun, bro. This is like physics, and
Yeah, this is
it was
fun.
pretty cool. I didn't. Okay, my only problem was I felt like I had to know something about like the way the thing curves to know like how it works, but at the same time, I feel like I didn't. But I'm pretty sure. I don't know, bro. I'm so confused.
I didn't use physics to solve this. I just used my common sense slightly, and then I was like, oh wait, that also makes sense from physics.
Bro, I didn't have to do any math.
Your
That
mom
was
Really?
did
part
have to
I
do
was
math.
both.
I had to solve the energy equations, but just without numbers. But I still had to do the math.
Energy equations from what?
You didn't use energy. I used energy.
So the only
I didn't make any math.
I used energy, but I talked about the conservation of energy. I didn't use equations.
yeah, I mean the only one where you even were allowed to use equations was the first one. If you used
Yeah,
equations on the
I
other
did it on
ones,
the first one. That's why I
Yeah.
have like a 10-sentence answer.
yeah. Um,
Giganto.
so yeah, the other ones if you used equations, you would have gotten 0 immediately. So just be very very careful about that. Anyway,
Yeah,
so
Alan.
let's look at this.
Hey,
Why do you say Alan?
she
You
always will
failed,
blame me
Alan.
for it. It's like, imagine living with Ethan just in your house all the time.
All right, you know what? Fair enough. Fair enough. Fair enough. All right, let me make sure my screen is actually being shared properly. All right, so say a physics class, friction slide. Yep. So we say that the height that the both blocks get released at is the same, right? Because you can see that from the line right there.
So cool.
I did not mean to duplicate that. That's fun. That's fun.
That you can read it but twice.
Wow.
All right, all right. However, the height that they start at is different, right? The second block starts lower. So, does block 1 and block 2 land at the same same distance from their respective tables? And the correct answer was no, they don't, which I think everyone got. I can't remember. I don't want to say things without checking though. So, but a lot of people got it.
Yeah, Alan got it wrong.
So, if you look at the rubric, the first 2 points almost everyone got. Let me zoom in a little bit more. Okay. So the first 2 points, which was, where's my highlighter? This. Which was that for attempting to use conservation of energy, compare the 2 blocks, almost everyone got, right? Because you just had to say the other one started higher, they at least the same height, more energy equals farther, right? And then most people got the second one, which is just saying that when they leave the ramp, the second one was launched at a faster velocity, so therefore it landed farther. The last one was the tricky one, and this one, not like very few people got it here, and also very few people got it nationally. It was the most missed point on the FRQ was the last one. The reason why you had to include and you had to mention that the time to reach the ground was the same for both blocks is because if you didn't, and it was possible for that they were launched with different velocity towards the ground, then just saying that they were launched with a different horizontal velocity would not necessarily mean that they would reach the ground at different times. So you had to explicitly say that the time to reach the ground is the same, or that its acceleration or velocity in the vertical direction is the same for both blocks. Because then that's when you can actually, say that because of that, the only factor determining the distance is their horizontal velocity.
Wait. So the actual reason that they hit the ground at the same time is because their vertical velocity will always be the same.
In this instance, the vertical velocity is 0 when they left it, because they both leave, like the ending of the ramps is both flat. So any variation of just saying that the initial vertical velocity is the same, is 0 or the same, anything along those lines would have been valid. But you had to acknowledge that, because if you didn't, and let's say hypothetically the launch velocities in the vertical direction were different, then you can't just say, oh, their horizontal velocities is different, so therefore they're different, because it could work out that the difference in the vertical velocity counteracts the horizontal one.
So they hit the ground at the same time or different times?
They hit the ground at the same time, but the other one launches farther because it's faster.
That doesn't see. I don't like that. That had to be a point though, because like the question wasn't really asking about that.
Right, but if you
Wait,
didn't
like
if you didn't know that, and you didn't know that the time to reach the ground is the same, it doesn't. Even if the velocity going sideways is more, based on the difference in height, an object that is traveling super fast, completely flat, versus an object that's fired at a 45-degree angle, the one that's fired at a 45-degree angle, even if it's traveling slower, could still land farther if it launches if it has more time to hit the ground. So if you know that that fits on at the same time, and you know that this one is moving faster than that one, then you know that this one will go farther. But if you can't
There,
make that connection, then might be part of the problem that you're missing.
Wait, but I thought-
that makes more sense than just like, oh, you know, you had to know that like the vertical is different.
But I thought the answer to the first one was that they go the same distance. Like they don't. One of them doesn't go farther.
What?
Isn't that the
The-
answer to the first one? Is
no.
that not the answer to the first
No,
one?
No.
that's the wrong answer.
Alright, never mind.
Block 1 and 2 do not land the same resistance or distance from their respective tables. No. They don't.
For B, that's not it.
No, we're on A. We're on A right now.
A. But we're
Where-
still on A. Oh,
Does it look
I
like
was
look
so confused.
look
What
at
is
look,
highlighted, Sehun?
Nothing.
if you look at
sense.
my screen, does it look like we're looking at B right now?
I wasn't looking at your screen. I was looking at my screen.
Well, maybe you should stop doing that.
Stop.
But again, that was the most difficult point to get. But it was pretty much like Alan said better than I did. If you didn't state that, then it would be possible for that answer to not be true, even if their launch velocities are different.
Mm-hmm.
And
Like,
there's an
yeah.
example answer there.
And
Go
to
ahead.
be fair, it's not. You wouldn't normally like doing the problem. I probably would miss that point too, just because I wouldn't think to mention it. But it's really important to show that you have understanding.
Okay. So, any questions on part A?
Wait, but I said in my answer that like when I solved it, when I like did all this stuff and like plugged it into the kinematics equation and whatnot, I said I said that the initial velocity in the x direction would be 0.
Who's speaking, Taehan?
Yeah.
You got all 3 points, so.
Yeah, but I don't. But I said they were 0. But then you gave me a point for implicitly indicating that the launch velocities are different, when I said that they would both be 0.
So the last sentence you have, I'm going to read it out. Says since v is greater for block 1, it will have a greater x value and go farther. That's the sentence we took.
Oh, I meant that for final velocity. But I mean that's chill.
So I mean, to be fair, like we're grading out like AP grader, so most likely you would still get 3 points. I mean,
I meant like final velocity, like when it slides off the table, and I meant initial velocity, like when you let it go with the top of the ramp.
so maybe that's what you meant. So good that you're catching yourself there. I still think you would have gotten 3 points if you gave this to any AP grader. Whether or not you deserve that is up to you. I still think just the way that the question is worded or that your answer is worded, they probably would have given it to you anyway.
Alright, cool.
But that's not to say that you should play the game like that. You should make sure you understand it. The one thing with AP, by the way, is there's no such thing as getting points off. You only get points, right? So you can say a ton of garbage, like literally absolute nonsense, right? But as long as you say the things that you get points for, you'll get the points. Now that's not to say that you can just say a bunch of random things and hope that one of them is right. That will, if they catch you doing that, then they won't give it to you. But for the most part, you can say things that are wrong, but as long as the things that matter for points are right, you'll get the points.
Basically, you'll never lose points for writing too much. Like as long as you can write, if there's something you can write down that you think might be important, write it down. No reason not to. Like for here, it's for the most part, you just kind of think, if when you're in the problem, you're like, okay, yeah, obviously they're gonna hit the ground at the same time because they have the same height. But if you don't specifically state that, then you wouldn't have gotten the point for it. So just always state things.
Yeah. So to be fair, I do see rereading the question again. I do see a little bit before that, Taehan, where you do say x is 0. So it's possible you may have gotten 2 out of 3. It depends on who's grading it. But do you understand what it's supposed to be? answer. Ooh.
Thank you. That was a beautiful response, Neha.
All right, well, we lost him.
All right.
All right, so the second question. I have to like move this down. Since all the answers are on one page. All right, so the second question was they have different shapes. So which one lands farther from their respective table? The correct answer was the two blocks land the same distance. And among the best ways was just to talk about energy, right? So you say their starting height is the same, their ending height is the same, start the same potential energy, they end with all of their potential energy being converted to kinetic energy, and they are launched horizontally, therefore they land the same distance, right? So the two things that you had to, is it moving? Yeah. The two things that you had to say was just that you had to indicate that the change of potential energy from release to launch is the same, and that the launch velocities are the same, and that would have given you both points.
I did the complete opposite. I didn't state any of that. But I had the correct.
Yeah, and that's one of the other thing, by the way. You can put, like if you actually look at the rubric right here, you'll see there are no points for actually selecting the right answer. Right? You can select the wrong answer or select the right answer, and it does not affect your points. It's only the explanation that affects your points.
Of course, if you get the points for those explanations, then you, for both of those, if you get both the points for the explanations, then and you make the conclusion that you get the wrong answer, there's something wrong in your mind if you can make those assumptions. But still, it is technically
Yeah.
possible to write the correct explanation and pick the wrong answer and still get it right.
Okay, so does anyone have any questions about parts A or part B or how we graded it for you? Any questions just in general so far? Okay. And so B part 2 was the hardest one. And it asks which block of either hits the floor. And the correct answer is block 1. Block 1 hits the ground first. And this might seem counterintuitive if you correctly got part B that they land the same distance, right? But so the way that I like to think about it is think about extreme cases. And if you remember back to the very first FRQ we did, which was about two masses and one is larger than the other, one smaller than the other, right? Similar thing there. One of the easiest ways to think about it was to think that one of them is like a giant boulder and the other one is a feather, right? So similar instance to this. If we were to redraw this slope over here to be super exaggerated, so it's like this, and then it just is off the table. Then let's draw this one as being super exaggerated, like it's like that, and then drops off at the last second, right? If we imagine this block, right, which can I use shapes? Yes, high quality. Okay, yeah. So if we imagine this block, it's going to go down almost at the speed of acceleration due to gravity, and then once it's at the bottom, it's going to have all of its velocity, and it's just going to go off the edge, like pretty much immediately, right? Because it converts all of its potential energy to kinetic energy at the very beginning of the slide. Whereas if you imagine block 2, right, it's going to go really slowly at the beginning because it is only very slowly converting its potential energy to kinetic energy. And only at the very end of the ramp, when it goes pretty much almost straight down, will it convert its potential energy to kinetic energy. And then it will have the same, launch velocity at the end and travel the same distance. But because block 2, in this case, spends much more time just sitting with only a little kinetic energy and most of its potential energy, it spends more of its total time on the ramp. Whereas the first block just yeets off the ramp as soon as possible. So that is why it is block 1 hits the floor first. And you can read their explanations. You had to say that the average speed for the slide is higher for ramp 1, or that block 1 reaches its maximum speed in less time. And you just had to explain why. So their example is over here. Bruh, I didn't leave the board. What are you talking about?
I mean, it says you are.
Whatever. All right. So, are there any questions about anything on this FRQ? Nothing. Everyone understands.
How does the scoring, other than like 4 out of 7 points, like how many FRQs are there?
There's one
There are 5.
experimental, like too long, too short, isn't it?
What the heck
Yeah.
does
So
that
I mean
mean?
that. Okay. So there are 2 short answer questions. There's one qualitative quantitative translation question. There's one experimental design question, and there's one paragraph length response question. And there's 5 total.
Bruh.
So the paragraph length response, qualitative quantitative translation, and the experimental design question are all worth 25. And then the 2 short answer questions, this is considered a short answer question, are worth 7.
I'm scared.
Well, that's why we're practicing.
Okay, no, hold on. What was the average score for the 2020?
I'm assuming you guys got 5s on this.
I got a 4.
I got 5.
I'm mad that I got a 4, but I got a 4.
Bruh. I'm trying to get a 1.
No, you're not. Listen, I'm really gonna tell you right now. You guys are definitely you have an advantage over everyone else in the class who's not here because you guys aren't doing any FRQs at all. And this is 50% of your test. I'll tell you right now, everyone else in that class who's not doing FRQs is going to struggle because these are very different. As I'm sure you've noticed, than everything Mr. Florence has given you.
And I want you to know, Sahil, that like when Alan took his FRQs and stuff, like when he took the physics AP exam, Alan went like really fast. Had he like slid down and actually thought about this stuff, I'm sure he would have gotten a 5. He talks to me about that all the time because I go really fast and make stupid mistakes.
Mhm.
So you're gonna 4.
Bruh.
I mean,
can't.
I was the actual.
The only thing I
opposite.
actually like fully understood was kinematics and energy, and then everything just like, eh.
I mean, to be
like-
fair, those are among the foundation of physics. Like you
So
use
Hill, that
kinematics
means
and
you
energy for all them.
understood the entire first quarter. That's
Yes.
first semester.
Bruh.
You guys did waves in first semester. Come on.
Okay,
but that's
you know what?
useless.
Waves,
Easy, though.
waves
We're
was
not
a
doing
fever
that.
dream.
I know,
Waves
I
was
know.
a fever dream. We don't talk about waves, alright?
Yeah,
Waves
so-
were just random in the middle of nowhere. He's like, here is some random number equations.
Yeah,
And
and
you've been
again,
doing stuff that felt practical up until now. Here's some non-practical stuff that makes no sense.
so
and then you
I'm,
get tested on it after 3 days.
I'm sure it would have felt practical if he actually went in order. Like if he did energy and similar harmonic motion stuff before waves. I think it would have felt practical at that point, but he
You
didn't.
could have been like Deganto, that we had a quiz on like the second day of school on like dimensional analysis and stuff, and then Deganto just quit the next Monday.
I mean,
I should have done it
it's the
too.
same thing.
I should have done it too.
Well, I'm actually glad I didn't quit because now, like, I don't want to take IB physics. I'm taking IB chem next year, so like, I'm not sure what field I want to go into. So
Good.
I have the option of like, I've taken both college.
Hey, I'm gonna tell you that is the exact same thing I had, and then I met Mr. Hick and I said, well, I'm not doing that.
Yeah, but I mean, like, Mr. Hicks sucks, all right. But however,
What's wrong with Mr. Hicks? I love Mr. Hicks.
What do you mean was wrong?
He managed to make everything boring.
Well,
Everything boring.
I actually don't think he's boring.
Then you haven't
Well,
named
him
him.
a student.
Sahil, you didn't have Miss Pryor, bro.
That's a fair point.
Honestly.
Oh my god.
Miss Pryor.
Yeah, that,
Pryor was
that
great.
says a lot.
Miss
I
Pryor
found this for
still
Albert.
caring.
If you ever feel bad about what score you're gonna get, put in what you think you're gonna get, like as an estimate in there, and that's the projected curve for 2021. It's not the actual curve, but it's the projected curve. So let's say you get like
got a 6.
you get a 40 out of 50 on your multiple choice.
For
You
what?
get
Alright.
like
Oh,
Go in
for
general.
physics.
It's in general chat.
yeah, if you get literally half credit on all of your half credit on all of your FRQs, you get a 4.
Half credit. One
Who the fuck
credit.
is eating
Two
chips
credit.
right now?
Nathan
Four
is.
credit.
It's Nathan. He's
16
been
credit,
eating it.
I've
I could just hear chomp,
64
chomp,
credits.
chomp, chomp, chomp the whole time.
I
I didn't say anything.
Mans want some chips, all right? What's wrong with that?
Like, you don't like some ASMR?
Okay, no, I don't need
Hey,
ASMR. No. That like literally, what I put in as my predicted is 41 out of 50 on multiple choice, and then a half credit for all of the FRQs, and that's a 4. Like,
That's pretty good.
yeah, like you don't have to be 100. Like if you get uh, it's not.
Yeah, if you get it's okay.
Shh,
Yeah,
shh.
and like I said, our average for this question was like a 3.9 error 4, which is double the national average. The national average was 2, and no one got below a 2, by the way. So no one got below the national average. So I think we're doing pretty well. I think you guys.
Wait. I'm sorry. Did you just say the average is also the lowest score?
No, for ours, no one got below a 2.
Oh, okay. I was about
Yeah,
to say.
Feihan,
I was
everyone got a
about to
5.
say. Alright, hold up. So
It's impossible for the average to be the minimum.
according
Like,
to this, I can get a 40 out of 50, and on multiple choice, and then a 5 on free response, and then 9 on another free response, and then 7 on another free response, and then 3 on the other free response, and get a 5 overall. So
No,
I'm
you
gonna have to
need
study
a
for
70
that.
out of 100 composite score to get a 5. It's a
I read a
70%.
stat-
70% to get a 5.
Wait, hold on. So that means the multiple choice can just kind of carry you,
Yep.
assuming you do good on it.
Mhm.
If you do good on the multiple choice, bro, you can literally get like middle scores for everything else.
Our expectations just
Well-
turn from getting 1s and 2s to 4, 3,
No,
4, 3,
that's what
4,
I've been telling Ellie all this time. She's like, "No, I'm just gonna fail." I'm like, it's kind of hard to do that if you know what you're doing.
Gotta
But-
fail, bro.
Okay,
to be fair,
but-
to be fair, you still like don't underestimate the FRQs though, because even if you get 100 on the multiple choice, you still have to get what is it, 20? You still have to get at least 20 on the FRQs to get a 5. So I mean, sure, if you get a 50 on it, you'll still get a 3. Like you're passing at that point, fine. But if you're looking for the high scores, you should still like don't be like FRQs. Joke.
No, I
You
can't
should-
bank on
don't
multiple
practice
choice
that.
anyways. I can never.
Yeah, because there will be some question. Like there was one question I remember, which was it was predicted trajectory for just like imagine a cannonball traveling through the air. You have an explosive charge that goes off mid-flight, and they showed you 4 possible trajectories, and you had to basically say which was the one that could be possible, because the other 3 wouldn't be. And I remember that question stumped me for a very long time. Because I was like, well, obviously, if there's an explosive charge, they're going to split off and go in opposite direction at the same speed. But there were 2 options that did that. You had to pay attention to is that one of them had the arc start to go up and down for one of the halves instead of just going straight down, and that was the defining factor. And I did not get that until afterwards when I asked him, like, what the hell was the right answer for this? How did you exclude the other one? He's like, yeah, no, it's because it went up. I'm like, oh. Big brain. And sometimes it's just going to be questions like that where it's stupid difficult and it's really, really conceptual and you just have to think real hard. And oftentimes
phone a friend.
you don't. Well, you can't phone a friend
Phone
during the
friend in
test.
middle of the test.
I
Also-
found
You
a
can't phone a
stat
friend in the middle of
that
the test.
I found a
Ask the
stat
teacher.
like yesterday that AP Comp Sci 50% of the students who take it get a 4 or 5.
You think that's bad? I think Chinese philosophy is like 80% of people get 5s. Or something like that.
Oh my.
That's because other people who take it are Chinese. They just know.
Ching chong.
Not
yeah,
quite what I
doesn't
said.
Physics have like one of the highest like 5 rates because people study?
No.
Or highest like pass rates.
No.
No, I remember seeing something. It's like
No, we have the highest failing
It's
rate.
the
Dave.
hardest one. It's the hardest one, but one of the hardest ones. But it's also like one of the has
No.
one of the best
Uh,
scores things
What?
because people study. Hold on, let me find it.
I
No,
I
Feihan,
don't know what you're
you are
talking
wrong.
about here.
Lowest
20% of
pass
people who take
rate.
this test get a 1.
These are the
I'm
hardest.
getting a 1! Oh no.
Yeah. Okay. So physics.
Oh, the true. This is the
C,
2020
okay.
score distributions, and
Okay, so
2020
here-
scores
here-
were shit.
In 2020, here are the pass rates. Spanish. it
Keep in
has
mind that
90%.
2020 is terrible because this was the year that they did everything online, and I can
Yeah,
tell
'cause-
you for a fact I did not earn a 5 on bio, but I
'Cause
got one
Physics
anyways.
C has an 84% pass rate.
Yeah, physics C. C. You're not taking physics C.
A.
You're taking AP
It's-
Physics 1.
Wait, is physics 1 harder?
Yes,
Oh,
because
physics
physics
1
C
is
is when you do
51%
calculus,
pass
and you're
rate.
doing physics 1, which is algebra, and that one is terrible.
Physics 1 is 51% pass rate.
I would
Yes.
definitely take that.
Oh god.
Is AP Euro that test hard?
I think I think I got a 4 in AP Euro. Euro wasn't that bad.
Euro has a 59% pass rate. Hold on. Okay, everyone
Okay,
take
but
music
you need
theory.
to know, Sahil, that Mr. Camp does a really good job on preparing us for this.
Yeah,
Yeah,
most
yeah,
of the
yeah.
IB teachers do a really good job on that.
No, and Camp is also, out of all the teachers, definitely the best adapted to online learning.
Oh yeah,
Yeah.
for real.
Except
The only thing I
everyone's
have
saying
issues with is the
a bunch of people are
test.
saying that
It's
he
the
does
testing so bad.
cahoots. He does cahoots with some of them that he doesn't do with us. Some of the, like once he ends the class early, sometimes he just does review sessions with them. Which
Yeah,
kinda
maybe,
sucks,
but still, I think
whatever.
it's pretty.
But that's okay. I mean,
Eh.
I guess.
Okay, yeah.
Fine.
So the 5 weight for Physics C is like
it's
41%.
better than when Dr. Florence forgot about us in the beginning of the year.
The 5 weight for AP
Oh, yeah.
Physics 1 is 8.8%.
Mhm. Because if you're because physics is way easier once you understand calculus. Like,
I'm gonna
it
be
just
in the
is.
93rd percentile, boys.
No, I'm
Bet.
gonna be in the bottom
Bet.
20 percentile.
I doubt
Get
it.
my 1.
I doubt it.
Such an overachiever.
Well,
I'm
you
gonna
guys
be in the
you guys
bottom
couldn't hear me that whole
0.5.
time, could you?
Oh.
No,
Nope.
Oh.
there
Nice.
was no chip ASMR.
I thought I turned.
You know, Japanese
the
language and
base,
culture, 53% 5.
Nice. I'm taking
AP
Japanese,
Chinese language and culture is
language and
55%.
Alright, I'm taking that.
Yeah, so
You're
what I
not
was trying to
Chinese.
say-
You're not gonna get a
Well,
What I
5.
was
you
trying
have
to say
to be
about
Chinese
physics.
still.
No, you don't. You just.
But okay,
Yeah,
yeah, but
that's
that's why the passing is so hard. Because people who are Chinese and Japanese just take it and get
Isn't
stupid higher.
Chinese the hardest? Isn't Mandarin like the hardest language in the world?
English is the hardest language in the world, my guy.
For
No,
real.
English is illogical. Mandarin
How
is
is
just
English
hard.
language like the?
Because none of our rules make sense. Our exceptions have exceptions. It's dumb.
No. He wasn't asking how
before
is it
he,
bad. He was
except
asking
after
why is
he.
English considered a language with all the problems it has.
Because
Yeah,
people
fair.
speak it.
Fair. I mean, also fair. No, but what I was trying to say earlier about Physics C is like everyone who takes Physics C is also taking calculus, so that's why the passing rate's so high.
Yeah, because
like,
calculus and physics are so fucking close, like intertwined. I literally have a book on my shelf. It's my favorite books, which is just about the relationship between advanced math and physics, because that's just how they developed advanced
You
math.
are such a nerd. What the
That
heck?
book is one of my favorite books. I swear,
Alright,
I will
well-
get it right now.
real quick before everyone starts dipping, couple things. So first of all, no other questions about the FRQ, right? Just to check.
Double dipping.
Nope.
All right. So we're gonna keep doing this. If anyone has any other questions about the test for tomorrow, by the way, feel free to ask since I'm done rambling here. Other question: If or would doing full length tests eventually, not yet, but eventually, would be of interest to anyone, or is that doo doo?
We need to get Albert logons.
I would like to do that. I would like to take a full multiple
We
choice and
we need
FRQ
Albert
test.
logons, Nathan. We need
I know,
Albert
so, like-
logons.
I know. I'll email Miss Baker again.
Aren't you guys gonna have a lot of pain?
Grading?
Grading that?
No, we won't. For
Oh, because you get cast hours.
no. Because Albert.io exists, and Albert.io is the the website you are going to hate the most and love the most when it comes to studying for AP tests.
Yay.
It's like they have what, like 300, 400 questions for AP Physics,
Oh yeah,
something like
somewhere
that.
in that range.
Yeah,
Oh,
and
shit.
it's across all the categories. They give you reasoning for every single question's answer and why it's wrong, and they have 3, 4 practice tests for each class,
Yeah.
and you'll
Is
just get
AP
access to that.
Is Khan Academy a good study? Is Khan Academy a good study thing?
Khan Academy is iffy when it comes to that stuff because they have
No,
the
well,
quizzes,
so
but
here's what I'll say. Khan Academy is
not
very good for
quizzes, for
understanding, for studying the topics. For AP Physics, I would say yes, Khan Academy is very good. IB is a different land, but for AP, yes, but it does not really do AP style questions at all.
right.
That's where I would say it has a problem. But the topics are spot on. I used that when I was taking AP Physics, and I found that to be very helpful for topics, but not
Yeah.
for questions.
To me, I just can't learn. Like, don't read the articles. Watch the videos. Don't read the articles.
No,
yeah,
don't read the
Khan
article.
Academy articles, like literally, like
That's
like
gay.
the videos. Like, don't get me wrong, I love Khan Academy, but I've always had a physical inability to learn from a screen. So like the videos alone, I have to rewind like every 10 seconds. I have to rewind 5 seconds to catch what he said.
Okay.
And then the
I'm gonna
articles, I
give you
straight up
this
just don't
because this
read
is the
them.
wisdom that Mr. Mills gave us. On any YouTube video that
I play
has
them at 2 times
subtitles,
speed.
on any YouTube video that has subtitles, you
Yeah,
can
I
get the
play 'em
transcript of
subs.
it.
I play 'em with-
No, you can get the transcript.
No, I can't read transcript. I suck at reading transcripts. What I do is I play them at 2 times speed with subs, and that kind of holds my attention because
Yeah.
Sal Khan speaking fast is kind of funny.
So with the transcripts, for example, let's say you have an assignment for your English class.
Oh yeah, obviously I use English transcripts. You know, you just.
Oh yeah, no,
highlight-
like that was the thing I never knew existed. You can get transcripts for YouTube videos. Like,
yeah.
oh,
And
Like
oh.
whenever. No,
How
no,
is the
like-
English AP English exam? Like, is that hard?
Well, I got
Well,
on
that
Lang
was
I got a
right.
4, on Lit I got a 2. So,
Well, I
And
mean-
what?
However, they revised the test for AP Language and Composition, didn't they?
I think that was the year that we took it.
yeah, we were the first ones to take the revised test.
Then I got a 4,
Well, so.
and
guess
then I
what?
took Lit.
Guess
I
what?
failed.
So the thing is, like, when Miss Hiltz is like, watch these videos, and you know we don't watch videos, no one pays attention. Like
Mhm.
afterwards, I just like open up the videos, and for the homework, I just open up the transcript and I just Control F and I just like.
That is the way to do
find
it.
whatever. She's like, what are the rhetorical choice? I just Control F choices. on
Have
the
you?
transcript.
Yeah. Have you watched the? Yeah, I mean, have you read your book? Taehan?
I'm almost done with it.
What the- I read one chapter.
I didn't read the book. I don't even have the book.
Okay, I'm just happy to know that I'm not the only person who hasn't been doing the work this year.
We've
Okay.
been doing the book project for a month right now.
Okay.
Oh.
Neil,